Alright, we are done with the first requirement, keeping track of all charges made from the user's bank cards. The second requirement we have is moving cash from snack machines to ATMs. We won't dive deep into it too much here because the solution is pretty straightforward, but I wanted to show you the end result and point out some key elements of the implementation. This is our dashboard. It displays a list of all snack machines in our system, as well as a list of all ATMs. You can see it also shows the balance of the head office itself and the amount of cash it stores. I've set all values to 0 to show you the actual workflow of transmitting cash from a snack machine to an ATM. To use a snack machine, we can display it by clicking on the Show button. Here, let's say for example that I want to buy a chocolate. I'm inserting $3 and buying it. After I close the window, you can see the amount of money in the list changes. I can now unload the money from the snack machine to the head office and load it to the ATM. Now I, as a user of the ATM, can take $3 from the ATM. You can see the balance of our head office has changed to $3.03, meaning that our head office just earned 3 cents. To implement the actual functionality, I added two methods to the head office class, one for unloading cash from a snack machine and another one for loading it to an ATM. Note that in the dashboard view model we use data transfer objects, DTOs, to display lists of snack machines and ATMs on the user interface. There is an important guideline when it comes to displaying data on the UI. Unless your domain classes are really simple, using them to display lists of data is a bad idea, because it almost inevitably leads to poor performance. You should prefer using special classes, DTOs, by default. The sole purpose of such classes is to just transfer data, nothing more. Here's the DTO for the snack machine entity. You can see it contains only an ID and money amount fields. In other words, only the fields that are required for the user interface. They also don't contain any business logic, because they are not part of our domain layer. This is the DTO for the ATM class. It looks very similar. Here's how we get a list of ATMs. I commissioned this responsibility to the corresponding repository. In this method, I use an Hibernate to transform domain entities into DTOs. Note that this is a shortcut, because despite the use of DTOs, we still load full domain entities into memory in order to generate the DTOs. It's basically fine if your application doesn't have a lot of performance requirements. If it does, you can fall down to plain ADO.NET or some lightweight ORM like Dapper and create DTOs directly without involving domain entities. This technique is referred to as CQRS, and the use of DTOs is one of its types. If you want to learn more about CQRS and different types of it, you can read my blog post here. This is how the getSnackMachineList and getATMList methods are used in practice. Whenever we need to refresh the lists, we use the repositories to fetch new data from the database and notify the user interface so that it can re-render it on the screen. In this module, we talked about domain events. Domain events is a great tool that helps us keep bounded contexts decoupled from each other. You saw how awkward code might be without them. Although communication between bounded contexts is the most common use case for domain events, they can also be employed for decoupling classes inside a single bounded context. We discussed 4 best practices for defining domain events. First, keep the naming in the past tense. Second, try to include as little data in a domain event as possible. Ideally, it should contain only the information that is needed for the external code to react on this event, nothing more. Third, don't include domain classes such as entities and value objects into domain events. It would introduce unnecessary coupling between bounded contexts. And finally, include full information about changed objects in case consuming bounded contexts don't know about the bounded context producing the event. In case they know about it, you can include just an idea of the changed entity. We touched upon physical delivery of domain events. The main point here is that how exactly domain events are delivered to consuming bounded contexts is orthogonal to the notion of domain event itself. The techniques for working with them in the domain model remain the same. You saw 2 ways of handling domain events. The first one, the classic one, relies on domain entities raising events directly via a static class. This approach has 2 drawbacks. The first one is that we damage isolation of our domain model because the innermost layer of the onion architecture in this situation depends on the infrastructural static class. The second drawback is that we no longer adhere to the unit of work concept. The domain events in this situation get processed before we commit the transaction, and that can lead to inconsistencies in case the transaction cannot be committed for some reason. The second approach doesn't have these shortcomings, and I advocate you use it instead. With the second approach, we separate two responsibilities, one for creating an event and the other one for dispatching it. That way, we keep our domain model isolated and also adhere to the notion of unit of work. You saw how to work with list of objects on the user interface. The guideline here is to avoid using domain entities to display data on the screen. Instead, use DTO classes by default. You can find the source code for all the demos in the course in the exercise files. I also created a GitHub repository with the final version of it. Here it is. Alright, that's it for this module. In the next one, we'll look at some DDD concepts we didn't discuss yet, such as domain services and factories. We will see what further enhancements our application can take in the future. We'll also talk about some common anti-patterns programmers employ when they start applying DDD principles.